All right, this is our last lesson for chapter 2, and this is all about how to write the names and the formulas of compounds, which we did during our review unit, so hopefully it's familiar to you, but this is just some extra practice. So let me just go over the rules one more time, and then we'll do some practice problems. The first thing is you have to recognize when something is ionic. So it's usually a metal and a nonmetal, so something from the left of the staircase, something to the right of the staircase, but keep in mind that you can also have two polyatomic ions, and in that case you would have all nonmetals. So it's not a hard and fast rule that you could have all nonmetals as well. But basically you'll have a positive ion and then a negative ion. The first rule is to name the first element just like it is. The second rule is that if it's not a polyatomic ion, if it's just a plain old element, change the ending to "ide." So chlorine becomes chloride, oxygen becomes oxide. If it's a polyatomic ion like sulfate, you don't change the ending of those. Step 3 is that if the first element is either a transition metal, which is in the D block, or lead or tin, so Pb and Sn, then you have to figure out what the charge is and show that charge with Roman numerals. And the way you figure out the charge is that the whole charge of the whole thing has to add up to 0. Sometimes they call it the net charge. And so you have to figure out what the negative charge is going to add up to, and then figure out what you would have to have as a positive to make the whole thing equal 0. And I'll do a couple of these with you in just a minute. And then the last thing is be careful. There are exceptions to the rules. Silver and zinc are the most common ones. You need to know those charges. So silver is +1 and zinc is +2. So here's some examples. I want you to go ahead and pause this video and jot these down on a piece of scrap paper or a sticky note, and then start up the video and you can check your answers. So the first one is just zinc chloride. Looks like zinc needs a Roman numeral because it is a transition metal, but it is an exception to the rule. Silver and zinc do not need it. The second one is copper 3 oxide. And I got that 3 because, first of all, it's a transition metal. That's why you need it. And if you look at oxygen's charge on the periodic table, it's -2, and I have 3 of them. So that makes it -6. So if the whole thing is going to add up to 0, then the copper needs to add up to +6, so that the +6 and the -6 will cancel out. And because there's 2 atoms, that means each copper is going to be +3. So copper 3 oxide. And again, that 3 is telling you the charge on copper. The next one is sodium nitrate. Do not change the ending to "ide" because it's a polyatomic ion. Sodium does not need Roman numerals because it is not a transition metal, lead or tin. The next one is lead 4 oxide, and 4 in Roman numerals is IV. This one is tricky because, first of all, it looks like lead does not need Roman numerals because it's not a transition metal, but it is an exception to the rule. And the second reason it's tricky is because a lot of people try to just use those subscripts. So if you put lead 2 oxide, you're not alone. A lot of people do that. But it's not those subscripts. It's the charge that lead would have to become to make the whole thing 0. So if oxygen is -2 and you have 2 of them, that makes it -4. And so lead has to be +4 to cancel it out. And then the last one is iron Roman numeral 2 sulfate. So again, don't change the ending of sulfate. And the reason I got that 2 is that sulfate's charge is -2, so iron needs to balance that out and be +2. And just be careful, it looks like you have 4 sulfates. It's tempting to say there are 4 of them, but that 4 is part of the SO4. It's part of that polyatomic ion, and so you actually only have 1 SO4. If you had multiple polyatomic ions, they would have to be in parentheses with how many you have on the outside of the parentheses. All right, let's move on to covalent. So for covalent, this time we're going to have 2 nonmetals, and they're the ones that are sharing electrons. This is a completely different way to name it, so just be careful that you don't start to confuse this with ionic. In this case, we're going to use prefixes to show how many we have. So like mono means 1, di means 2. The only exception is we don't use mono for the first element. So for example, capital C, capital O is just carbon monoxide. We do use mono on the second element, we just don't use it on the first one. And then the last thing is you're still going to change the ending to "ide." That shows scientists that the elements are chemically bonded together. Be careful, a lot of people think things like SO3, it looks like sulfite, it looks like a polyatomic ion, but if it's all alone, then it's going to be called sulfur trioxide. So tri is the prefix for 3, and then you change the ending of "ide." The reason it's not sulfite is because sulfite is the name of a polyatomic ion, and to be an ion, it has to have a charge. So either you will physically see the charge, so like what I have there in the second bullet, SO3 -2, you can physically see the charge there. or you can bond it to something. So in that last example, the last bullet, calcium sulfite, it's the polyatomic ion sulfite because that's what's sticking it to calcium. If it didn't have the charge, it wouldn't stick to calcium. So even though we don't write the charge, if it's bonded to something, it does have a charge. So it's sulfur trioxide only if it does not have a charge and it's not bonded to anything else. Just like before, take a minute and pause this. I just gave you one of those examples a minute ago if you're listening, but see if you can write these down and then check your answers. So the first one is, like I said, carbon monoxide. Mono means one and there's only one oxygen. You just don't use mono for the first element. The next one is dinitrogen pentoxide. So you do use di for the second one. And oxygen is a little weird because it starts with a vowel. So a lot of times scientists will drop the vowel ending of the prefix so that you're not saying pentaoxide because it's a lot of weird sounds like So they just make it pentoxide and drop the A. So again, dinitrogen pentoxide. And then the last one is sulfur octachloride. Don't forget to change the ending. All right, next we have acids, and acids you name differently based on how many elements are bonded. So first of all, they usually start with H to indicate that they're an acid. Remember, acids, their whole job is to donate that H+. If it's binary, bi meaning two, that means it's only hydrogen and one other element. It does not mean you have two atoms. So if you look at that example, there's 3 atoms in that acid, but there are only 2 types of elements. That's why it's binary. And in that case, you're going to say hydroblankic acid, and you fill in the blank with the other element. So in this case, H2S is hydrosulfuric acid. If you have more than 2 elements, so they call it ternary, or sometimes they call them oxyacids, the main thing is don't start the prefix with hydro. Hydro tells scientists that it's binary, so if it has a polyatomic ion, you cannot use hydro to begin the name, even though you will see hydrogen first in the compound. And then you just use those 2 rules. So 8 turns to ic and ite turns to us. So H2SO4 is an acid. It starts with H. SO4 is sulfate, and 8 turns to ic, so it becomes sulfuric acid. And then that last one, SO3 is sulfite, so ite turns to us. And again, notice no hydro because it's ternary acid. These are mixed up, so some of them are ionic and some are covalent. So again, pause the video for just a minute and grab some scratch paper and go ahead and see if you can write these names, and then I'll go over them after you play the video. The first one is ammonium. If it has 4 hydrogens, it's ammonium. 3 is ammonia. So ammonium sulfide. The second one is carbonic acid, no hydro. P2O5 is diphosphorus pentoxide. MnO is manganese, Roman numeral 2, oxide. HCl is hydrochloric acid. HNO2 is nitrous acid. NO2 is nitrite, so it becomes nitrous acid, no hydro. Ag3PO4 is silver phosphate. You do not need Roman numerals on silver, even though it's a transition metal, it's an exception. CaBr2 is calcium bromide. No Roman numerals because it's not a transition metal. N2O7 is dinitrogen hept oxide. The prefix for 7 is hept, H-E-P-T-A. And then the last one is tin Roman numeral 2 fluoride. So you do need Roman numerals because tin is an exception to the rule. Tin 2 fluoride. Just a few more things. Diatomic means there are 2 atoms. So di is 2, atomic is atoms. And there are 7 elements that will always bond to themselves if there's nothing else to bond to. So if you have a sample of hydrogen, then each hydrogen is going to find another hydrogen to stick to because they can share their electrons and it makes them stable. So just make sure that you know these 7 elements and that whenever you write them in a reaction by themselves, they need to have a subscript of 2. Now, when you bond them to something, that subscript is no longer there, then you would cross the charges. You no longer have to memorize these, so don't worry about memorizing them. Peroxides are, the only peroxide I think you'll ever see is probably H2O2, but these are ones that have oxygen atoms that have single bonds. Oxygen almost always forms double bonds, so it's kind of unique for it to have it as a single bond. And H2O2 is the only one that I've ever seen anybody ask about. All right, hydrates are actually new. You did not learn these in honors chemistry, but they're not too bad. They kind of incorporate some other things that you do know how to name. So first of all, a hydrate is an ionic compound that has a certain number of water molecules attached to each compound. And so you're going to see the ionic compound, and then usually it's a dot. I just put a star. That's the best I could do. That's not multiplication. That's just like a dot. And then you'll see a coefficient that tells you how many water molecules are bonded to that compound. So the ionic compound, you name it just like normal. So this example would be sodium sulfate, no Roman numerals because it's not a transition metal. Then you use the covalent prefix for the coefficient in front of water. So in this case, we have 3, so it's going to be tri. And then you say hydrate afterwards. All right, for writing formulas, this is if I give you the name and ask you for the symbols. For ionic, don't forget to put your charges and cross them down and then simplify. For covalent, you don't simplify, you don't do charges, you just write the number that the prefix tells you. And then for acids, start it with H. Use the name to figure out if it's H in one element or if it's a polyatomic ion. So again, if it has hydro, it's just one element. If it's no hydro, then it's a polyatomic ion. And then you can tell from the ending which polyatomic ion to put it with. And don't forget to cross your charges here too. So both ionic compounds and acids, you do have to cross charges. All right, here's a few formulas. Take a minute and see if you can write these out and pause the video. And let's check and see how you did. The first one is Cu, capital S. So those two charges cancel out. The second one is C2H6. Do not simplify that because they're not charges. Phosphoric acid is H3PO4. Don't forget to bring that 3 down from phosphate. Iron 3 phosphide is FeP. And those cancel out as well. Iron is +3, P is -3. Calcium hydroxide, be careful here. Make sure you put parentheses around the hydroxide. So calcium is +2, hydroxide is -1. So when you bring that 2 down, it doesn't really look funny without the parentheses. But it is wrong if you don't put parentheses. So it should be Ca and then OH in parentheses and then a 2 on the outside of the parentheses. The next one is just capital H, capital I, hydroiodic acid. And the last one is Cd. And then Cd is +2. So then bring that 2 down to the fluorine. So CdF2. And that's it for today.